For years, we all know what's most expected from Tesla is something really affordable, not out of reach. And now, in Tesla's Q2 2025 earnings call, they're giving us a real reason to get excited.
We continue to make investments in various aspects of manufacturing.
And that'll make the affordability dramatically greater.
But things are not just about cheaper EV. Tesla is hinting at a full rethink of how their cars are made. Faster, smarter, and at a scale that could shake up the entire market. All this change is building up to the long-rumored Model 2, a compact EV that could launch under $9,000. In today's video, let's see how revolutionary the Model 2's production plan could be, and when over 2 million of these cars could finally hit the road. But before we start, let's support autogearshift by hitting that subscribe button and help us reach 7,333 subscribers. Thank you so much. How 1980s style car building still keeps EVs expensive. For more than 100 years, car manufacturing has been rooted in a labor-intensive, multi-step process. A traditional internal combustion engine vehicle contains over 30,000 individual components, each with its own supply chain, quality control standards, and installation protocols. Both traditional AVs and EVs' fragmented structure directly impacts cost, as manufacturing alone accounts for 52 to 60% of the total vehicle cost. For electric vehicles, which add the complexity of battery pack assembly and thermal management systems, the cost challenge becomes even more severe. Battery cells themselves are not cheap. Even with advancements in lithium-ion technology, average pack costs in 2024 remain around $130 per kilowatt-hour. For a compact EV with a 50 kilowatt-hour battery, that translates to $6,500 just in battery cost before any margins, labor, or supporting electronics. This is why even the most affordable EVs on the market, such as the Chevrolet Bolt or Nissan Leaf, start above $25,000 and often climb higher with options. The problem with traditional car manufacturing is not just the cost of materials. It goes deeper into how vehicles are physically built. Every vehicle is constructed step by step, with each part added in a specific order. These steps are not only numerous, but also tightly interdependent. A delay in one component, such as brake calipers or dashboard modules, can stall the entire production line. On average, assembling a car using traditional methods requires between 20 and 30 labor hours. This figure does not include the additional time or complexity involved in fabricating parts at external Tier 1 and Tier 2 suppliers, or transporting them across multiple regions. All of this adds cost, time, and systemic fragility. Now picture the inside of a typical automotive plant built in the 1980s. Loud hydraulic presses shape steel panels. Overhead conveyors move partially assembled frames from station to station, and dozens of human workers manually tighten bolts using power tools. It is precisely this outdated system that Tesla is working to overhaul. Do you think it's time we stopped building EVs like it's still the 1980s? Comment yes if car manufacturing needs a complete rethink. What makes Tesla's approach to the Model 2 different enough to achieve affordability? To build an electric vehicle that costs under $9,000, Tesla cannot simply reduce part costs or negotiate better supplier deals. The problem lies deeper, within the very architecture of automotive manufacturing itself. At the heart of this shift is Tesla's decision to eliminate geometric complexity from the car's structure. Instead of constructing the underbody from over 100 individually stamped and welded parts, Tesla uses massive die casting machines to form entire sections in a single press. This is not just automation, it is a form of structural minimalism that removes dozens of opportunities for error, misalignment, or material waste. However, redesigning the car's structure is only one part of the transformation. Tesla has also reimagined the way vehicles move through the factory itself. In most automotive plants, the assembly line follows a strict sequence. One broken robotic arm or delayed part can grind the entire chain to a halt. Tesla is replacing this sequential logic with a modular production flow. Each major section of the Model 2, such as the front chassis, structural battery, and rear drive unit, is assembled and tested independently in parallel. Once each module is ready, the final vehicle is essentially snapped together at a central unification station. Internal estimates suggest that this model could reduce total vehicle assembly time by more than 30%, while also enabling smaller and more flexible gigafactories closer to the end markets. The final pillar of this new production philosophy is the battery, not simply as an energy source, but as a core structural element of the vehicle. Tesla's aluminum-lithium hybrid battery introduces multiple breakthroughs at once. Chemically, the substitution of aluminum helps reduce dependence on scarce and volatile lithium markets, while improving thermal stability. Structurally, the battery pack is no longer an isolated box suspended beneath the car. Instead, it becomes the floor itself, integrating directly with the front and rear castings. This removes the need for secondary supports, crash cradles, or complex enclosures, reducing the vehicle's total weight by up to 15% and increasing overall rigidity. Taken together, these three strategies, casting, modularity, and battery, Tesla is expected to cut Tesla's production costs for the Model 2 by 42 to 48% compared to the Model 3, without compromising safety, range, or performance. Can casting, modularity, and structural batteries really make a sub-$9,000 EV possible? Comment Model 2 if you think Tesla's onto something big. Beyond just streamlining the production line, how does the Tesla Model 2 drive down costs without sacrificing utility? The answer lies in Tesla's strategic use of high-efficiency materials and a minimalist design language that simplifies construction while preserving performance. A large part of Model 2's efficiency also comes from Tesla's innovative choice of materials. For example, the Model 2 utilizes 6000 and 7000 series aluminum alloys in its castings, selected for their high strength-to-weight ratio and excellent corrosion resistance. These alloys offer tensile strengths up to 500 megapascal and are ideal for large cast structures due to their thermal stability. Where steel is used, Tesla prefers ultra-high strength hot-stamped boron steel, especially in door intrusion beams and side sills. This targeted use of materials allows the Model 2 to remain lightweight without compromising safety. The estimated curb weight is under 1,400 kilograms, roughly 15% lighter than a Nissan Leaf or Chevrolet Bolt, both of which rely on multi-piece stamped structures. Aerodynamically, the Model 2 benefits from a highly optimized body form with a drag coefficient around 0.23. This is achieved by eliminating traditional design inefficiencies such as exposed door handles, side mirrors with large bases, and underbody gaps. Tesla uses flush surfaces, closed-off front grills, and a full-length aerodynamic shield beneath the car to reduce turbulence. Lower drag means better efficiency, and that directly extends range. With the aluminum-lithium hybrid battery pack integrated into the floor pan, the Model 2 is expected to achieve between 330 and 350 miles per charge, while using a smaller battery pack than the Model 3. Crucially, all of these choices do not come at the expense of durability or lifespan. Tesla uses a high-resilience powder-coated underbody to prevent corrosion, and advanced acoustic dampening within the cabin to ensure comfort without added weight. The simplicity of the design also facilitates maintenance. With fewer components, diagnostics become easier, and repair cycles are shortened. Tesla expects the Model 2 to have a total ownership cost over 10 years that is 30 to 40% lower than ICE vehicles in the same price bracket, thanks to reduced mechanical wear and fewer service interventions, 30 to 40% lower ownership cost over 10 years. Do you want to jump on this chance? Comment ready if driving smarter and saving more sounds like your kind of move. The Tesla Model 2 isn't just cheaper parts or faster machines, it's a whole new approach to car manufacturing. With smarter engineering, simpler structures, and better materials, Tesla proves world-class quality can be affordable. Do you think cars should finally be this smart and accessible? Share your thoughts below, and thanks for watching.